We've talked about various examples where people copy the behavior of others, and particular ones in which they copy others' behavior because they learn from what other people do. A classic example of that is thinking about the restaurant story, where when you look at restaurants, if you're choosing between two alternatives, the restaurant with more people in it perhaps is a better choice because you can learn something from what other people have done in choosing that restaurant, perhaps about the quality of the food or the desirability of the restaurant. What we want to do now is begin to develop a theory, first starting with some very simple intuition for how this works. That is, what are the basic ingredients of information-based copying the behavior of others? And our model is going to need to capture three features. First, that people make decisions sequentially. Second, that everybody has some private information that they know and only they know. And third, that people get to observe what others do, but not what they know. So you can see the choices made by others who chose before you, but you don't get to see directly what it is that they know. A simple way to do this is to look at an experiment. And this is an experiment that's actually been run, but we'll talk about it really as a thought experiment. Imagine that an experimenter is going to place an urn on the table, and this urn is full of balls. People are going to draw balls out of it. What every participant in the experiment knows is this is one of two possible urns. One urn has a majority of red balls. The other one has a majority of blue balls. And those two urns are equally likely. The experimenter is going to choose at random between the two. The way the experiment is going to work is 100 people each draw one marble from the urn, and then they replace it. So you draw a marble, you look at it, you put it back, it gets mixed up. Next person draws a marble, looks at it, and puts it back. You don't show your marble to anybody else. That's the private information. The sequential aspect here is that people are going to be asked to guess sequentially whether the urn on the table is majority red or majority blue. And they get paid. Let's suppose if you guess correctly, you get $10. If you guess incorrectly, you get nothing. Every person hears the guesses of those who've guessed earlier, but remember, they don't see the actual marble that person drew. The person drew it and put it back. So let's think about what's going to happen here. Let's start with person one. Person one has a marble. Suppose that marble they have is blue. Well, clearly, if they're going to make a guess, they're going to guess it was the blue urn. That's the only guess that really makes any sense here. What about person two? Well, if person one drew a blue marble and therefore guessed blue, person two hears the guess of blue. Now, they didn't see that one drew a blue marble, but notice that the only way one's going to guess blue is if he drew blue. If he'd drawn red, he would have guessed red. So two, in making his guess, knows what one drew, or he can infer it from one's guess. What's two going to do if he too draws a blue marble? Well, then clearly he's going to guess blue because he has two observations of blue. What if he draws a red marble? Well, now he has one inference of blue from one's guess of blue and one actual observation of red from his own draw of red. Let's suppose in that case, when he has equal numbers of blue and red, he follows his own draw. Seems like the reasonable thing to do rather than following your inference of the other person's draw. So let's suppose two guesses red in that case. So two, notice, is going to guess his own color, in fact, regardless of what one did. If one sees blue, two will guess blue if he draws blue and red if he draws red. And similarly, had one drawn red. Two follows his own draw. Three, however, is in a very different position. Suppose, for example, that one and two both guess blue. Let's think about three's problem. And let's think about it first before three even takes it into account his own marble. If three sees two guesses of blue, then three knows that in fact one and two both drew blue marbles. Now if three has a blue marble as well, then he's got three draws of blue and he of course guesses blue. But what if three had drawn a red marble? Well, now what he knows, having seen two guesses of blue and drawing red, is that there's two observations of blue and one of red. That still makes blue more likely than red, so the good guess for three is to guess majority blue. But notice now what happens is that if one and two have guessed blue, three is going to guess blue regardless of what he actually draws. He guesses blue if he draws blue or if he draws red. So three's guess doesn't tell anybody anything about what three actually drew. What about four? Well, if one and two guess blue, we know three's going to guess blue no matter what he drew. So 4 is going to see 3 guesses of blue if 1 and 2 guess blue. Now, only 2 of those guesses are informative. 3's guess doesn't say anything because it was independent of 3's draw. But 4 is in exactly the same position as 3. He too is going to guess blue regardless of his draw because he's got 2 draws of blue he can infer from 1's and 2's guesses. And no matter what he draws, it makes blue more likely than red. So he guesses blue. But notice what's happened now. 3's guess was independent of his draw. 4's guess was independent of his draw. And that's going to continue forever. So remember, the story here is that we started with the example in which 1 and 2 both drew blue and therefore guessed blue. And now we can see is that everyone after that guesses blue regardless of what they see. So we have a blue cascade generated simply by 2 draws of blue. Had the initial 2 draws been red, we would have had a red cascade. So we can generate cascades here very easily. And in a cascade, what happens is we're getting lots and lots of guesses of blue, but actually they don't convey any extra information beyond what we saw from the first 2 guesses. So if you're looking at the 100th person to guess, that person may see the previous 99 people guess blue. All he really knows is that 1 and 2 saw blue. He has no idea what the others drew because they're all guessing blue because that's the best they can do. That's exactly what you see in a cascade. That's going to be very important for understanding what happens in our analysis of learning from the behavior of others.